Hi guys, Ms. Rosacker here. I hope you were able to get outside and enjoy some nice weather this week. And here is our last video for week number 3. So what we're going to do is we're going to work on solving polynomials and finding the number of solutions and the type of solutions based on their graph and the equations. So we're going to start with graphs. And what we're going to do is we're going to try to figure out the lowest degree for each of these graphs, the minimum number of real solutions, and the minimum number of complex solutions that they have. So remember, all of our polynomials had real or complex, and these complex ones are just the ones that have that imaginary aspect to them. So let's start with A. So first of all, let's remember how we find the degree. So the degree of a polynomial based on the graph is equal to the number of max mins plus 1. Okay, so for this first one, I only have one minimum right here. So our degree is going to be that one minimum plus 1. So this is a degree 2 polynomial, which does make sense because this is a parabola, so it should be a degree 2. So then the next thing we're going to do is we're going to try to figure out the number of real solutions, the number of complex solutions. So we have real solutions, and real solutions are just where it crosses x-axis. So these are real x-intercepts, so things that actually cross the x-axis, whereas the complex solutions are the other type of solutions that don't touch the x-axis. Okay, I probably shouldn't have written that so close. Let's do real first. So if we go back to this graph, we can see that this crosses the x-axis at that point and at that point. So that means that I have 2 real solutions to this polynomial. So this has 2 real solutions. Now, the only thing that you also need to know is just that your degree gives you the total number of solutions that you should have. So since this is a degree 2, we should have 2 solutions. So at this point, we know that we are done and that we have 0 complex solutions. So another thing you probably want to have written down is that the degree equals the number of solutions. So that's how many solutions you should have at the end of this. So this is a really, really important one, especially when we get into our next learning for next week. Okay, so let's do B. So let's see, I have a minimum here and a maximum here. So if I add 1 to that, this is going to be a degree 3. So that means I should have 3 solutions. So first thing we look for are the real solutions, which is just where they are crossing the x-axis. So I can see there's 1, 2, 3 places where it's crossing the x-axis. That means we have 3 real solutions. And then they match. So this is a degree 3. I found all 3 of my real solutions. So that means that I have 0 complex. Okay, moving on to C. So in this one, it's a parabola again. So again, you have 1 minimum here, add 1 to that. This is going to be a degree 2. And then if I look at this graph, I see that there is no place where it touches or crosses this x-axis. So that means that I have 0 real solutions. Now we know this is a degree 2, so there should be 2 solutions. So if I have no real, then that means that I have to have 2 complex. So these always have to add up to be whatever your degree is. Okay, let's do D. So we've got a maximum and a minimum, add 1 to that. This is going to be a degree 3. Second thing we do is look for x-intercepts. So I only see 1 x-intercept right there. And the rest of this graph never touches or crosses the x-axis. So I only have 1 real solution. And then if we know all of our solutions should add up to 3, that means I have to have 2 complex or imaginary solutions. And then that's how you identify how many of each type of solution you should have. Okay, next thing we're going to do is I'm going to introduce solving a polynomial, which really just means we are trying to find all the solutions to the equations where you have your polynomial equals 0. So this is just your polynomial. Okay, so what we are going to do is we are going to try to just start working on solving this problem and trying to get down to what all of my solutions would be. So the first question you're going to be asked is, how many real solutions could this have? So we know by looking at the degree, this is a degree 3. So there is a possibility that there are 3 real solutions. There could be. I think there's also the possibility of there being only one real and two complex or something along those lines. So there could be 3 real solutions. So what we're going to do is we're going to try to check and begin to solve this. So what our whole goal is we're going to take a polynomial that looks like this, and we're going to begin to factor it. Now, at this point, you guys have no idea how to do this factoring. So let's just say I did something that you're going to learn in the next couple of classes, and I got this expression to equal this expression where we're starting to factor it down. Now, I want to just check and verify that if I take this x minus 2 times this x squared minus x plus 1, that I end up getting the same polynomial back. So we're going to our area model, and we're going to just multiply this out. So what we're doing in here is we're taking this x minus 2, and we are multiplying it by this x squared minus x plus 1. So we're multiplying those out. And remember, when we do this, we're just multiplying the edges of these boxes to get the inside. So to get this box right here, I'm going to do x times x squared. So that means this box is going to be x cubed. And then to get this box, I'm going to do negative 2 times x squared. So this becomes negative 2x squared. Then to get this one, I'm going to do x times negative x, which becomes negative x squared. Then to get this one, I'm going to do negative 2 times negative x, so this one becomes 2x. Then to get this box, I'm going to do 1 times x, which is x. And then to get this one, I'm going to do negative 2 times 1, which is just negative 2. Now, one of the most important things that we want to recognize and realize is that our like terms are always going to be diagonal each other. So a diagonal right there is my x squared. Diagonal right here is my x's, and then these are the two that don't have like terms. So now if I want to get what this inside is, when I actually take this times this, I'm just going to add all of these things together. So I know it starts with x cubed. And then I'm going to combine these because these are my like terms. So negative 2x squared minus x squared becomes negative 3x squared. 2x plus 1x becomes positive 3x, and then I still have the minus 2. So now what we should have noticed is that we got this original expression to be the exact same as the answer that we got out. So what that means is that these two things multiplied together give us the same expression, which means that these two things are equal to each other. So now I think we can take this and solve if we were to set this equal to 0, because we know how to solve this expression and we also know how to solve quadratics. So we're going to take this and we're going to move over to this box and we're going to solve this out. So what we just realized is that we were able to take this equation and factor it into x minus 2 times x squared minus x plus 1, right? Yeah, and then we're going to solve that for 0. So what that means is that these two expressions right here in the green are equal to each other. This one is just easier to solve because now I can take each of my factors and set them equal to 0 and solve. So what we're going to do is we're going to take this first factor, x minus 2, and we're going to set it equal to 0. So if I take x minus 2 equals 0, and I'm just trying to solve for x, this one's really easy. You just add 2. So one of my answers is going to be x equals 2. And now we are going to write these all as points. So remember, this is where x is 2 and y is 0, because that's what my equation is going to be. So this is going to be 2 comma 0 is going to be my actual solution to this. So let's do my solutions in pink. So that's one solution. Now what we're going to do is we're going to take the second equation and set it equal to 0 and solve. So we're going to take x squared minus x plus 1 equals 0, and we're going to solve. Now this doesn't factor, it's not factorable. So we're going to have to use the quadratic formula to solve this out. So I'm going to move over here just so I have a little bit more space. So we're solving x squared minus x, is it plus 1, equals 0. We're going to use the quadratic formula. So let's review. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this one, we've got our a value is 1, our b value is negative 1, and our c value is, I didn't write it, is 1. So what we're going to do, did I mess that up? Nope. So what we're going to do is we're just going to plug that in. So we got x equals negative b, so negative 1, plus or minus the square root of b squared, so negative 1 squared, minus 4 times a times c, so 4 times 1 times 1, all over 2 times a, which is just 1. And then we're going to start simplifying. So if I have a negative 1, this becomes positive 1, plus or minus the square root. Negative 1 squared, negative 1 times negative 1 becomes a positive 1. And then, excuse me, I'm going to do all of this together. So negative 4 times 1 becomes negative 4. over 2 times 1, which is just 2. Okay, and then we're going to simplify the inside. So this becomes 1 plus or minus the square root of negative 3, because if I do 1 minus 4, it's negative 3 over 2. And then we know how to simplify this now. So I know that if the square root of negative 1 is equal to I, that means this has an imaginary solution. So I'm going to break this up into negative 1 times 3. And then I know this square root of negative 1 right here becomes I. So I'm going to take an I out. I can't do the square root of 3, so that stays in there. So this becomes 1 plus or minus I squared root of 3 over 2. And that is what x equals for this problem. Now, remember, we're writing these as points, and this one gave us 2 because we have plus or minus. So one of my solutions is going to be x equals 1 plus I squared root of 3 over 2, and the other one is going to be 1 minus I squared root of 3 over 2. And when we're solving this, we're writing these as points. So to take this first one and write it as a point, remember this is x. So I'm going to write 1 plus I squared root of 3 over 2, comma, y is 0. So that's going to be how you write your solution. And then 1 minus I squared root of 3 over 2, comma, 0. So then these are going to be our two other answers that are complex. Okay, so let's go back over here. So we had those two solutions. We had 2, 0, and then we also had the ones I just wrote over there, which were 1 plus I squared root of 3 over 2, comma, 0, and 1 minus I squared root of 3 over 2, comma, 0. So then these were our other solutions. Now, the first thing we want to check is this was a degree 3 right here. So we should have 3 final solutions whenever we are done. So let's write this is solutions. And then we're just going to answer some questions. So this one says, okay, how many x-intercepts does this have? Well, we know these two solutions are imaginary, which means they don't cross the x-axis or touch it. So this is the only x-intercept that you have. So you only have one x-intercept at 2, 0. So then it says how many real roots and how many non-real roots or complex roots do we have? Well, we have one real solution, one real root, which is the 2, 0, and we have 2 complex solutions, which are the other solutions we have written over there. And we have a total of 3 because it's a degree 3. So that's our whole goal in trying to solve this, is we're just taking these down, trying to get them to be quadratics, and then solve using the tools that we have. So that's how you guys are going to work on beginning to solve this. I don't know that you do one of these in your homework quite yet. Okay, and then the last thing we're going to do is we're going to go through this real quick. It says sketch a 3rd degree polynomial with 3 real solutions. So if I have 3 real solutions, that means I have 3 x-intercepts. And if it's a degree 3, it should have 2 max-mins total. Okay, so I'm going to sketch myself a little graph here. I know it has to cross the x-axis 3 times, so let me just draw 3 times in here. And then I know it has to have 2 maximums and minimums. So I'm going to just start up here. I'm going to go through here, through that x-intercept, and then through that x-intercept. And then I can see it as 2 max-mins. So that would be a 3rd degree polynomial that has 3 real solutions or 3 x-intercepts. Okay, what about a 3rd degree polynomial that only has 2 real solutions, which means that it only touches the x-axis or crosses through the x-axis twice. So 2 x-intercepts. So the only way that this one is possible is if you have like a bounce happening somewhere. So let's draw my 2 x-intercepts. And I know my ends have to go in opposite directions because it's an odd degree. So let's start down here this time. So let's see, I want it to go through this x-intercept. And now if I want it to just go through or touch here, this has to be a bounce and go back up so that I have my 2 max-mins and it only touches my x-axis once. So this is how you could have 2 real solutions and still have that degree 3 polynomial. Okay, last one, degree 3 with only 1 real solution. That means only 1 x-intercept. When I look at this problem, I'm going to compare it to this one. I could have this real solution and then I can move this part of my graph up so it doesn't touch the x-axis. So let's put 1 x-intercept here. So I'm going to just cross through and then I'm going to do my maximum, but now I'm not going to let that minimum go all the way down the x-axis. So that's how I could have my 2 max-mins and I only cross through the x-axis once. So this one's going to have 1 real solution and then it's going to end up having 2 imaginary solutions because it is that degree 3. So here's the one question that I want you guys to think about for a second. It says, can a 3rd degree polynomial have no real solution? So is it possible for any of these graphs to never touch or cross the x-axis? Now, the only way that that's possible is if we're taking this part of our graph and shifting it up. Now, if we continue to shift this up, this end of my graph is going to continuously go down forever and ever and ever. So even if I shift this graph up, this part of my graph is eventually going to touch the x-axis and cross through it. So this is not possible. Every third degree polynomial will have at least one real solution. So one place where it crosses the x-axis, which is going to be really huge for us whenever we can solve these polynomials. Okay, so your guys' homework tonight is really on just determining how many solutions things have, being able to solve quadratic equations using the quadratic formula. So really being able to do like this problem right here, taking your time using the formula, and then just kind of practicing multiplying numbers. So you're really just going to practice multiplying things like this so that we can get into dividing polynomials next class. And really that's it. That's it for the week. I hope you guys had a good week this week. Please reach out if you need anything. And that's it. Bye, guys.